Hi all, welcome to this introductory course on astronomy and astrophysics. This lecture would primarily deal with an historical perspective on this topic, on how the ancient world viewed this and how our current understanding of astronomy and astrophysics in general came into view. So before we go into the historical perspective, it is very important that we understand what these words or what these words really mean. Even though we use astronomy and astrophysics and even cosmology in popular culture a lot, it's if you look at those words precisely, each of those words have a very precise meaning. So let us start with astronomy. What does astronomy mean? So let's say you're someone who enjoys watching the night sky, and at night you watch the night sky, and you ask the question where the objects are. That is basically astronomy. You just ask the question of where the objects are in the night sky. You don't ask the question of what the objects are. You don't ask the question of how the objects came to be. You may name those objects, but you wouldn't question how the objects emit light. If you ask those questions, that's where astrophysics comes into view. So, in a more technical perspective, we can say that the science of measuring the position and characteristics of heavenly bodies is basically astronomy. And the application of physics to understand this astronomy is basically astrophysics. So if you are to look at these two terms properly, this is how these two terms are supposed to be used. But in the modern perspective, we do use these both words interchangeably. Why? Nowadays, there aren't many astrophysicists who do not do astronomy. Like in the old times, there used to be a group of people who would look at the sky, who would map the skies, who would have a catalog of where and how these objects would stay and move. But in the current situation, we have telescopes which are automated, and this astrophysicist itself kind of contribute to that. So the line between astronomy and astrophysics are kind of blurred when it comes to this modern age of astronomy and astrophysics. So now next comes the next question. So if this is astronomy and this is astrophysics, what is cosmology? How can you say the term cosmology is different from both of this? So let's say you ponder about the question of how the universe formed, how it evolves, how it ends. That is where cosmology comes into play. So in a very proper definition, we can say that it's a scientific study of the large scale properties of the universe as a whole. You don't look at a sun, you don't look at a star, you don't look at a planet. You look at the universe as a whole. You look at the galactic clusters. You look at how the universe formed, how it is going to end. All those questions are the questions which are relevant when it comes to cosmology. It's a cosmology. So now now as you understand what those terms really mean, like when we go through a course on astronomy and astrophysics, it's primarily important that we understand what is astronomy and astrophysics and cosmology so that you know what you're doing. So let us now take a step back. Let's go to the ancient times and see how it all began, how the ancient people viewed these topics. So if you look at the ancient recorded impressions of all this, we know that the early humans made observations of the night sky. So how do we know that the ancient humans made observations of the night sky? We have written records, as we'll see. We have cave drawings of such phenomena being recorded. So what all did they observe? They observed that there were the movements of the sun, moon, planets, stars. They also noticed patterns in the sky. We humans, as a species, are very good at pattern recognition. And they name these patterns as constellations, and these are all things which we are very familiar with. And this has been done by our forefathers thousands of years ago. So one such impression is the Nebra sky disk. So it's nearly 1600 BC. That is, you add 2000 to it, nearly 3624 years ago. We have this 30 centimeter bronze disk, which has a sun, a moon, and all this Pleiades cluster and all depicted into it. This is from the northern Europe. So basically, what this shows is that our ancient people are very curious about the night sky. Our forefathers were very, very curious about what's there, and they did question. They did. They didn't. They may not. They may not have understood what these are, but it really did matter to them on where they were, what they were, and they were really curious about it. So, considering this, we can say that astronomy is the first science because it's the first thing we properly recorded, along with, I would say, grains and all. Like they used to keep stock of amount of grains, livestock, and all. But as a science, astronomy, they started keeping records of how the planets moved, where they were, and all those questions which they had. They kept a proper record of those. And you can see one such civilization which kept detailed records were the Babylonians, nearly 1600 BC. That is, we are 2008, nearly 3624 years ago. They are among the first civilization to develop astronomy. Like they made detailed observations of the night sky, and they also developed a system for dividing the day into 24 hours and 12 months. They also predicted eclipses. So basically, what they did was they had like the king. The king basically had people to look in the sky. Why? They usually believed in all these superstitions. They believed that heavens would give them information on how or what is about to happen. It was very important for the royalty to understand what happened or what the heavens showed. That was one of the primary reasons why the kept king had a particular team about how team on team to keep record of all this. So most of this data were put in clay tablets. These clay tablets, unless and until exposed to water, they would stay same. And they had people to make sure that if such a clay tablet got destroyed, it was replaced by a new one. So such a very meticulous system was in place in Babylonia to keep track of what the sky showed at night. It's from the Babylonian, this data. Like Babylonians had the data, but it's not the Babylonians who questioned it, who came up with the physics of those data. It was about 1,000 years later, that is nearly, I would say, 2,500 years before today, the ancient Greek, they inherited the astronomical record from the Babylonians and applied the data to construct cosmological framework. This is very important. Primary idea of physics is to interpret what we see around us. We do not pick up things. What we primarily do is that we observe what is around us and we try to understand the observations. So the Babylonians had proper observations on the astronomical scale, and it was the Greek who came up with a proper setup to a cosmological framework to explain those observations. And the Greeks made significant contribution to the astronomy. They developed the geocentric model of the universe, which we know is not right, but still they they are the ones who pioneered it. The thing which we need to understand it, the whole physics which we know that we're wrong, let's say geocentric universe. They didn't come up with these ideas just because randomly. We came up with this with proper rational thinking based on the technology available then, based on the rational thinking they did. It's not that they came up with something which was completely wrong without randomly came up with a story or something. What they did was that they thought about what they saw, and with the limited technology, with their understanding about the universe, they came with their philosophical, with the philosophy embedded in it, they came up with this ideas. So we shouldn't think that they came up with random stuff. They came up with proper stuff based on all these things. When we speak about the Greek philosophers, I wouldn't go through every one of them. We would look into a few which are very important, but it all like there are many people, and this list is not exhaustive. Like, it's not exhaustive. You would have many more philosophers in between, but there's some prominent figures who contributed, Greek philosophers who contributed to this idea of the astronomy. That is, they properly interpreted the data they got from the Babylonians. So this is primarily the geocentric solar system model the Greeks came up with. And we have the Earth in the middle and Moon orbiting Earth. Then we have Mercury. Then we have Venus. Then came Sun. Then we have Mars. Then we have Jupiter. And then we have Saturn. So this is what they believe the skies were like. And after all this, they had the big sphere in which the stars were embedded. So this is something which the Greeks came up with. Not that they did not. It's not that they were wrong. It's that that is what they could make sense of what they saw around them with the limited technology and with their philosophical understanding. So we'll start with Aristotle. Like there are philosophers before him, but Aristotle had a particular place because it is his physics, its ideas that kind of laid a foundation the way Newton did, how the Newton changed. So Aristotle had these views. He was someone who believed Earth was sphere. As I said, he did not believe just because he thought, oh, sphere is nice. He had his own reasons to believe that Earth was a sphere. One is the lunar eclipse shadows. If you look at the moon during a lunar eclipse, you can see the Earth's shadow cast on the moon and it looked like a circle. So for a circular shadow, the Earth has to be a sphere. So that was the reasoning that was given for why the Earth was believed to be a sphere. Similarly, shifting of constellations was also given. So when you are on the Earth's surface, when you are here, you have a particular constellation here, there will surely be differences based on here when you're standing here and standing here. So that was the reason why they uh, why Aristotle believed that Earth was a sphere. He also rejected the motion of Earth, that Earth is moving, Earth is not revolving, or everything moved around her. That's what he believed. So what is really important is that why did he believe that Earth did not move, that Earth was stationary? That is what is more important. One was the lack of understanding of emotion. I'll explain what that is. Let's say I'm standing here and I have a bowl with me. Let me just input this more data. Okay, I am on the surface. This is me. I have a ball with me and I throw the ball up. If Earth were moving, as per Aristotle and the school of thought, as per Aristotle's school of thought, what would that be? The Earth was moving a bit. The ball which I threw from here would land here because Earth has moved that much and I would be here. That was the idea. Like there was no idea of inertia that the Earth would land at the same place. The idea was that if you throw it from here, from A, if the Earth moved under, then even though we move, it would land at B. Why? The Earth as a whole moved. That was the idea. Like they did not understand inertia. It was Galileo who came up with the idea of inertia. It was then Newton who made it the first law and all. So yeah, and along with that, they could not observe any stellar path. Let's say we are in the Earth. We are at the same. This is Earth, and we have some stars. Some stars. Okay. If the Earth as a whole was moving, then these stars would appear to shift when we look from the same position. But what happened was that the technology then was not that strong so that if you look from a single position to see the parallax effects. So that is why he rejected the motion of the earth. Finally, here comes the philosophical part. Here comes how philosophy really matters to all these things. They thought that the celestial objects were perfect and unchanged, and they advocated for the principle of uniform circular motion. So they believed that all the celestial objects, they had this religious belief, they had this heavens being there in the sky. So they thought that all these spheres were perfect spheres and they would move in perfect circles. So that is a perfectness which they really wanted. So that is how Aristotle's school of thought was relevant in the time of the Greeks. As we saw in Aristotle's setup, that uh, Earth moved, and when Aristotle moved, we had this issue. Now, even though that was there, even though they all believed in the idea of geocentricity, that is Earth in the center and everything moved around Earth, there was some, even before Copernicus, who came up with the so sun-centric or heliocentric theory. And his name was Aristarchus of Samos. That's nearly 1,000 years before Copernicus. He proposed the heliocentric model, sun at the. So what you need to understand here is that why did they reject the model? And it's very important. So he did come up with this idea, and it was not rejected. Oh, simply there were particular reasons which, why, yeah, some of the reasons were philosophical, some of the reasons were kind of religious in ways, but at the end there was a reason. Some of the reasons were based on observation. One of the primary things is the lack of perception of motion. I told you. But in here, we have the similar situation. There's no feeling of Earth's movements. And this is only addressed by Newton's laws of motion, that they would understand that even though Earth moves, there's inertia and all those things. So that you wouldn't feel that Earth is moving. It's all because of inertia. Then came the missing parallax, as I've discussed just before on how Aristotle viewed the universe. Again, first parallax was measured in 1838. Again, one of the main reason was this pre 1500 technologies. And this was the philosophical aspect I was talking about. They thought circles were perfect. They thought it was more perfect to say that oh, Earth is in the center. They had this egoistic view on everything that oh, we are humans, we are the center of everything. So that did play a very big part in all this. And this was the heliocentric solar model our Aristarchus proposed, but no one really accepted it at that time. It took nearly 1,500 years later for the Copernicus and the other data to properly make us believe it. So when we speak about geocentric model, the name which comes always is of Ptolemy. It's not any of the other Greek philosophers. It's not that Ptolemy is the one who came up with the idea. It's that he is the one who summarized everything, all this Greek astronomy and ideas into his great book called the Almagest. It literally means the Almagest. It's nearly 13 books. And many of the Ptolemy's works were based on Hipparchus. He was another Greek philosopher, natural philosopher. And Ptolemy is generally given credit because he perfected it. So even if you look at Newton's first law, it was not Newton who came up with the first law. It's kind of like Galileo came up with it. But Newton gave it a very good structure and everything to it so that it has. So, what was the arguments Ptolemy put forward? It was not just his arguments. When it comes to Ptolemy, we get a very general idea about how Greeks thought about everything. So, the arguments which we gave for geocentrism were that falling objects would not fall down if Earth moved, as I told you before. Like, if an object falls to a point A, it's supposed to fall to point A, If Earth moved, it could fall to point B instead of A. Why? Earth moved beneath it. So they did not understand the concept of inertia. Similarly, objects thrown up, yeah, the same thing, based on the discoveries about motion. This, it took Galileo and Newton to come and show that, oh, we don't need this. We have inertia. That is why we don't, if Earth moves and we go somewhere else. That was the reason. Then he said that the planetary order was Earth, Moon, Mercury, Venus, Sun, Mars, Jupiter, and Saturn. These are what it's given in this book. Then one of Ptolemy's primary contribution was trying to explain the retrograde motion. So what is a retrograde motion? So we do not know that Sun is at the center of the solar system. We think that Earth is in the center of the solar system. If you are to view from Earth and if you are to see the motion of the Mars would look like this. The motion would look like this. So if this is Earth, if this is Earth, and the Mars were going around it, if Mars was going around it, so you wouldn't feel that it's always going in the circle. After a particular time, you would see that this would go in the opposite direction, something like this. So they could not explain this, how this was happening. So it was very important for it to like they were trying to explain this, and it is Ptolemy who came up with an idea. He came up with the idea of epicycles and difference to explain this. This idea was not Ptolemy's per se. This idea was Hipparchus, and he was trying to explain how the sun doesn't move at the same pace if you look, if you see its motion. So he kind of took the idea from Hipparchus and he applied it to our geocentric solar system. And what he did was that he kind of pushed Earth away from the center, and we have a circle with this new center, and it is called a different. And the planet wouldn't just go in the circle, the planet would again orbit a point in the circle, and that orbit is called the epicycle. So, if such a motion, they would give or explain the retrograde motion which we observed. So, what really happened was that I did not explain the retrograde motion perfectly. They had to give in epicycles on epicycles on epicycles, sometimes trying to explain all this. But this is one of Ptolemy's own important. Before we go into the scientific revolution, let us recap what did we learn till now. We started with understanding what the terms really mean, what astronomy means, what astrophysics means, and what cosmology means. Then we came to the understanding that our predecessors, the ancient humans, did look at the night sky, and the Babylonians started recording the night sky, and the Greek gave it a proper mathematical framework to the recordings of the Babylonians. So the mathematical framework or the mathematical idea of geocentricity was completely shattered by the scientific revolution. I told you, even though the Greek did have a rational backing, it is not primarily scientific. It was not completely correct. It was in Europe during the scientific revolution it all completely changed. When it comes to astronomy, the person who completely shattered the idea of the geocentricity was Nicholas Copernicus. Yes, we did see Aristarchus who did come up with the idea before, but the technology, then the ideas, then the philosophy, then did not make the people accept that idea. When it comes to Nicholas Copernicus, even though the geocentric idea was accepted as dogma by the church, it was he who completely changed from the Earth-centered model to the Sun-centered model. That is what we call the heliocentric model. So the heliocentric model he suggested, or the Sun-centered model he suggested, is not exactly same as the model which you are familiar right now on the elliptical orbits and all. The model which he suggested did not have Earth at the center, and the moon did go about the center of gravity of the Earth. That is, we did have an Earth in which the moon goes around it, but not the sun and other planets. And everything else orbits the sun and not the Earth. One thing which he retained from the geocentric model which the Greek developed was the circular orbits. And that did come up with its own problems. He did not give up with the idea of epicycles and difference, that is, moving the sun from the center and other objects orbiting another orbit around that orbit. So he did not change that, but what he changed was that he changed uh, the Earth from the center and put the sun at the center of everything. So the impact which this idea had was tremendous. It completely changed the view how we viewed the universe. That is, we thought the universe was centered around Earth and us, and we came to the understanding that no, it's the sun which is in the center. We are just orbiting around the sun. Then it completely helped in separating theology and cosmology. As I said before, the church had accepted the theology, accepted the Greek ideas and all, or geocentrism and all, and it was during this time slowly everything changed. Then it laid the groundwork for the future discoveries of Kepler and Galileo. We will go to that. We will listen to that. And the limitations were, as I said, it was more complex in the Ptolemaic system, even though it could explain the retrograde motion by bringing in sun of the center, because it kept to the idea of circular orbits. The epicycles had to be increased so as to explain observations. And it did not explain the planetary motion fully, again, because why? Because of the circular orbits. The primary issue with the Copernicus model was the circular orbits. Now let us look at the model suggested by Nicholas Copernicus. As I told you, in this model, we do not have the elliptical orbit, but we have a circular orbit. And that we can see here the sun. This is the sun, and we have here the planet. So as you can see, the center of this orbit is not the sun, but we have a distance between the center and where the sun is located, and we call it the center of the deterrent. And in the orbit, again, the planet does not orbit around the circle, but it again orbits in another circle which is centered at this circle, and we call this the epicycle. So this is the idea. This is the idea. This is the heliocentric model Nicholas Copernicus came came with. But again, this is not the true view of the solar system as we know right now. But the relevant thing is that this really changed how we see all this. That is what is relevant. It's a paradigm shift from how the Greeks thought of the universe as centered around the Earth in a geocentric system, and how the church took that system and made it the dogma. Finally, Nicholas Copernicus is the one who started the change, the one who started the change from the geocentric to the proper heliocentric. Now comes, as I told you, with every scientific system, we need to have observations. The guy who came up with the astronomical observations to explain this is Tycho Brahe. So what did Tycho Brahe do? Tycho Brahe has this amazing observational results or observational data from which we could say everything which we know right now. I would say his students, one of his students is very famous, come to him, has derived what we know right now. So he basically built the Danish observatory using sextants. You can easily Google what sextant is, basically used to the position and all. Since telescopes were not invented yet, a point side note, telescope was not invented by Galileo, it was invented by Hans Lippershey. Galileo just used that to observe the skies. So remember that always. So yeah, there is a very big misconception that Galileo is the one who invented the telescope. It was not him. It was Lippershey, and he just used it for another thing. So Tycho Brahe, with his observatory and with his sextants, made accurate stellar positions and measurements of his time, during his measurements of his time. So it is like the first modern accurate database of these objects, the positions, how it moves and all. And using trigonometry, yes, used that sun was much, much farther away than the moon. Then we could not detect stellar parallax. Hence, we supported the geocentric model. And as a compromise to Copernicus' view and Tycho Brahe came up with a different model in which we have the Earth at the center and the Sun is orbiting the Earth. But again, what Mercury and Venus was orbiting the Sun. So he came up with a what you say a hybrid model in which there is a geocentric system in which around the Sun we have a micro heliocentric system embedded in a geocentric system. So this is the model Tycho Brahe came up with. Now, a student, his pupil is going to completely change. The fact that Tycho Brahe believed in a geocentric system kind of hindered the work of Kepler because Kepler believed in a heliocentric system, a system centered around the sun. So it is only after Tycho Brahe's death that Kepler could completely move to his work with his data and come up with the theory of the heliocentric. So basically, what did Kepler do? He predominantly worked on Brahe's work. As a student of Tycho Brahe, and using Brahe's precise data, it is he who predicted or replaced the circular orbits with ellipses. Hence, this eliminated the need for epicycles. So, even though Copernicus came up with the heliocentric idea, he could not uh, remove the idea of epicycles. We had to add more epicycles so as to account for the observation. But it is when the circular orbit was replaced with the elliptical orbit that everything made sense. And thus came the three Kepler's laws of motion, laws of planetary motion, which you all know. And I'm sure you would go into this more detail during your classical mechanical study. I'm not dwelling more into it. I guess first years would have already gone through this. So yeah, that's how Kepler came to the laws of planetary motion. And this is Kepler's heliocentric model, and we have here the sun at the center, and we have an elliptical orbit and not a circular orbit. So that's how Kepler came up with the idea. That's how Kepler modified the heliocentric model proposed by the Nicolaus Copernicus. Now, here comes another paradox. You remember in this initial start of the lecture, one primary hindrance was the physics. The physics taught by Aristotle and the school. The physics which did not believe in inertia, which thought that everything you need force, you need to continue applying force for it to be in motion and all those. This and everything changed when Galileo came into picture. So, what did Galileo do? Galileo's primary innovations were he developed the laws of motion, natural versus force, rest versus uniform motion. The first law of motion, which we attribute to Newton, is primarily innovated or discovered by Galileo. And he used the small telescope, a 3-inch refractor, to observe the sky. This is very important. Why that is? If you remember, I told you that even though during the time of the Greeks, they did have a rational thinking on how to come up with these cosmological ideas or the idea about the planets and all, they were constrained by the philosophical view of how the universe should be, how the universe should be very perfect, how the universe should have perfect circles, how the object should be so perfect. So that philosophical idea was completely shattered by Galileo. He observed all these imperfections, sunspots, lunar mountains, Milky Way as a countless star. So once these observations came into view, it completely shattered that idea. Again, he came up with observations which cannot be explained by the geocentric idea, which is so prevalent, which are the phases of the Venus and moons of Jupiter. See, if there are objects which orbit the Jupiter, how can we say that everything should orbit Earth? So that is how this big paradigm shift when it comes to physics happens. So that everything is basic physics shifted from Aristotle's view to Galileo's view. Then Newton suddenly will come into picture and he will smooth everything out. And as I told you, this is how like Galileo observed the sunspots. And it is because of this we primarily say that at the end of his lifetime he lost his eyesight because he used to look a lot at the sun. Then we have the moon with a lot of craters and all. Then the Milky Way with lots of stars. Similarly, uh, like this is, I think this is Galileo's writing himself. Galileo's notes on uh, moons of Jupiter and the transit of Venus. Now, as I told you, the guy who completely, I would say, from that old view to the view we have, a kind of view we have. Like even after this, we do have issues, but the kind of view we have is all foundation as well as guy. So we have the philosophy in Nats Principia Mathematica, which we in short say as Principia. Then we have again, he came up with the three laws of motion, laws of universal gravitation, and finally derived the Kepler's laws of motion from Einstein. So this, in short, is how everything, how the ancient viewed the astronomy and how from there we reached here. So let me recap quickly. We had the Babylonians with their observations, then Greeks who tried to explain this observation, and they predominantly had the geocentric system. Then from them we have the Europe and the scientific revolution, the Renaissance. From there we get all these people, and we end with Isaac Newton. So I guess you have a fairly good idea about how all this came to. So that's the end of the session, and we'll meet for the next session. And before that, we'll have an activity session where the primary goal is for you to come up with an idea of your own cosmology to explain how the universe came to be or how the universe works. But you have to keep in mind we are born during the time of Aristotle and not pre 1500 AD. That is before Galileo and Nicholas Copernicus and all those people. So I want you to come up with your own idea, and we'll have a session where you all present your idea. So that's it. See you this Thursday. Thank you all.